As you can see, this lesson is on areas of circles and sectors. You should be very familiar with finding the area of a circle. We know that it is based on the radius, and we simply multiply pi times the square of the radius. So our area is pi r squared. We've been doing problems like this for several years probably. The area of a circle whose radius is 2.5 centimeters, we simply plug into the formula and see that it is 6.25 pi. If you want an exact answer, if you want to estimate it, you can plug it into your calculator, and that gives us approximately 19.63 centimeters. In problem B, it actually gives me the area and wants me to find the diameter. Now, since my area formula doesn't have diameter, it has radius, I'm going to find the radius first and then convert it to the diameter. So I'll plug in my area of 113.1. I'll have to divide by pi first and then take the square root, and it comes out to be approximately 6. If my radius is approximately 6, then my diameter is twice that, or approximately 12 centimeters. Let's talk about sectors. Now, this is something that's probably new to you. A sector of a circle is a region excuse me, is a region bounded by two radii of the circle and their intercepted arc. You can see this sector here is shaded in yellow. Sector APP is bounded by the radii AP and BP and the arc AB. So to find the area of a sector, what we're going to look at is the ratio of the area of the sector to the area of the whole circle, and that'll have to be equal to the measure of the arc compared to the 360 degrees for the entire circle. So this is very, very similar to what we did in finding arc length, except what we have is, instead of the length of the arc over the circumference of the circle, this time we have the area of the sector over the area of the circle, which is proportional to the measure of the arc over 360. So if I want to find these sectors, notice I have a red sector and a blue sector here, and I'm going to find both of them. First, I'll start off by getting excuse me, the measures of the minor and major arcs. We already see that we have a central angle of 70, so that makes the measure of the minor arc 70 degrees, and the measure of the major arc then is 360 minus 70, or 290 degrees. So the area of the small sector is what we're looking for, so that's x. The area of the circle, since my radius is 8, pi r squared would be 64 pi, is equal to the measure of the arc, which is 70 over 360. So that's just solving the proportion, cross multiplying and dividing, shows me that it is about 39.10. Now, to find the area of the larger sector, I have two options. One is to use my same formula, but this time my measure of my arc is 290, cross multiply and divide, and I get 161.97. There's actually another way I could have done that. I could have taken the area of the circle and subtracted the area of the red sector, and I should get the same thing. 64 pi minus 39.10 should give us the same answer, approximately 161.97. So, guided practice, here's one for you to try. First thing it asks you is simply to find the area of the circle D. You should have gotten about 615.75. Now, how did we get that? We said that area is pi r squared, so the area was pi multiplied times 14 squared. Finding the area of the red sector, it comes out to be about 205.25. How did we get that? we said, okay, our area of our red sector over the area of the circle, which we just found to be 615.75, is equal to the 120 over 360. And solving that gives us 205.25. The area of a blue sector comes out to be about 410.50. We can do that in two ways. We can say that x is to 615.75 as the measure of this arc, which will be 240, since the whole thing is 360, and solve that. Or we simply could have done 615.75 minus the area we found before, and that also gives us 410.50. So here we're given the area of the sector and we're asked to find the area of the circle. So we still use that same formula. We're just plugging our numbers into different places. My area of my sector I know this time, and I'm looking for the area of the circle, so we solve the proportion and we get 315. Okay, let's put some of this together. We have a rectangular wall that has an entrance cut into it, as seen, and we want to know the nearest foot, the area of this part of the wall that we're going to paint. So what we'll need to paint is the big rectangle, the whole wall, minus the entrance. The entrance can be divided into a square, which is seen right here, and a semicircle, which is right here. So the area of the wall is the area of the rectangle minus the cutout area. So I'm simply plugging in my numbers. 36 by 26 for my rectangle. Half of the circle, 180 over 360, times the area of the circle, which is pi r squared, plus 16 squared, which is this square right here. So this part is the semicircle, and then the part in blue is the area of the square. So we do our arithmetic and we come out with 579.47, so that makes C the correct answer. There's another one for you to try real quick. Comes out to be about 9.0729. Now how did we get that? Area of the sector over the area of the circle is equal to 85 over 360. Cross multiply and divide. Now this area is made up of a couple of things. First, we have a triangle. So I'm going to have to find the area of that triangle, and then we've got a semicircle. Looks like it comes out to about 43.74. Now how did we get that? The triangle plus the semicircle. The triangle is 1/2 the base times the height, 1/2 of 7 times 7, plus the area of the semicircle is half of the area of the circle, and the area of the circle is pi times r squared, which would be 3.5 squared. So you can do that to figure out the entire area.